Today it's Wednesday, March the 15th, and we have a board set up, board part number 61HVMPEC06 for MPE cathodic. Tony here was kind enough to configure a board just like that, and we started with 150K for R24, but right now we have a decade box on R24 and we have changed that to 249K. So we're going to show how the board behaves when we set it up for a 0.85 to 5.85 SIG HI voltage. We have test point 5, it's our reference. We have test point 3, and we can measure either the duty cycle or we can measure the delay angle of 5 to 3, and we're also going to take a look at the output of AC controller. So the setup here, it's pretty much this. We're going with 480 coming in through the line. We go through 3 pairs of SCRs and anti-parallel, and we measure the output at the load, and we have a lamp load on the back, on top. This meter, it's measuring our input 482, and right now we don't have SIG HI is 0.0, it's basically 0. We don't have an output, that's why we only measure 5 volts, and we can see here that the output is there. Now we can see that test point 3, I'm going to go ahead and add the duty cycle. That's a frequency. Measure the duty cycle. Where's my duty cycle? There's a duty cycle of channel 3, of channel 1, the blue channel. Alright, and right now we have only 7.2, which is 7.1%, that it's equivalent to 167 degrees. So let's go ahead and start increasing SIG HI, Tony. So we see it, and you can probably stop by around 2.5 volts. That's good right there. 2.45 volts. The output is 110 volts AC. We starting to see our lamp load glow. We got here our output, and we notice now that the duty cycle of test point 3 now it's 34.2%, which is equivalent to 118 degrees. Let's go ahead and go to 5 volts, Tony. That's good. We got 5. That's fine, Tony. 5.04. 466. It's our output. And here we have our waveform. That's starting to look like a true sinusoidal wave. And we have for 5 volts, 30 clear display, 82% duty cycle of test point 3, which is equivalent to 32 degrees. Let's go ahead, keeping in mind that we have R24 equal to 249K. Therefore, we need to go to 5.85. So can we go to 585? There you go. That's good right there. 5.84 volts DC for SIG HI. Now we have 475, very close to 482. And if we look at that, this is now our output waveform, and here we can see the notches for the 10 degrees that we are not firing. So at this point, the duty cycle is 94.2%, and the delay angle is 10%. So here we have, and here we have the 10 degrees. That if we were to calculate this by the duty cycle and go 1 minus 0.94, that's 0.06 times 180, those are the 10 degrees that we are not firing. So I'm going to go ahead and ask Tony to inhibit. Tony, can you change that to 150? And can you please bring SIG HI to 0? So now we have 150K. Double check it. And now we're at 0. So let's go ahead and do the same thing. Can we enable? you've enabled.
About 2.5.
480, that can go 2.5. That's good. 249, 280, 51%, 88 degrees. And now let's go to 5, because again, now we've configured it to 5 volts. Alright, that's good. 480, 477, the same output. And here we have the same 94.4% duty cycle. Again, the 10 degrees. The last thing that I want to point out is that the board, again, was configured. This is basically the connection diagram that we use. We varied SIG HI. And we only changed R24 from 150 to 249 to change that 0 to 5 for 5.85, and we have PP1, that switch right here, as open, 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 close, close, closed. And the only thing that I'm asking you to do is to go on the back of the board and verify that where you have open, you in fact measure open for that particular position, and where it's supposed to be closed, that you measure short circuit between that specific position. So this is the end of this video.